And to tell about him, he's the Director Research at Pi2 Software Labs. And he is also the founder of Null, the open security community, and also the founder of NullCon Security Conference. So welcome, Asim, and all over to you for your session.
Thank you. Thank you. So yeah, first of all, thank you for having me for the session. And yeah, so I'm going to be basically talking about. I will give you a brief idea about why IoT security, and then what I've been working on IoT security. That is basically the framework that I've built. I think this is already covered, so let's not go through it. In my free time, I build a lot of open source software, and I give trainings on IoT security and mobile security at various conferences. All right, so the agenda for the discussion today is that I'm going to talk about the attack surface, how it has evolved over time, and what are the IoT security issues, and what are the different kinds of attacks that we are seeing. And then I'm going to be talking more about why and how of the project that we started. All right. So, I mean, if you look at, decades ago, pre 21st century, before 21st century, the IT infrastructure was pretty straightforward. You had within the IT infrastructure, you had client systems, and you had some security softwares or systems like firewalls, and then you had internal servers like FTP server, web server, and so on. And so it all started with the hackers and researchers trying to attack and find vulnerabilities on the server side software, getting into the infrastructure, and exploring the systems. And then the trend started where bad guys also looked at the opportunities and figured that it is profitable to basically attack an infrastructure through their attack surface, which is their servers, and then get inside and steal information. But over time, this changed, and when researchers started finding vulnerabilities in client-side software like browsers, Office software, Adobe software, the bad guys also figured that, hey, if we have to really get some information, and it becomes pretty difficult to go and attack the server and through that pivot and get into client machines and then steal data. Rather, I think this is very simple if we directly attack the client machines. So people started exploiting browsers and all these things, and then over time, typically your IT infrastructure started to evolve with people bringing in mobile devices, storage and analytics moving from your local infrastructure up to the cloud, to an extent that now we have n number of devices on the infrastructure which we are still not aware of. So now if you look at the new target, it is, everything is just connected, whether it is your healthcare system, whether it is your retail system, your enterprise infrastructure, industrial infrastructure, everything is connected. And all of this is connected through, all these small sensors and devices. So if you look at the attack surface, it has just become huge. Like, this has exploded because every part of the infrastructure is now an exposed and attack surface, and this is going to, this is not going to end. I mean, we are going to be connected to such an extent that even humans are not going to be spared at the end. So we will have limbs, we will have organs, we will have chips connected to ourselves, which will connect us to the internet. So now the whole dynamics of attacks and exploits have tremendously changed, wherein an attacker can cause real damage or physical damage with just a click of a button. Imagine causing a DDoS or a DOS on something that is that is operating on humans, for example. And typically we are also seeing a lot of medical devices also coming up. So from the security perspective, let's look at what are the security issues. So over the years, if you see, when we in again in the 90s, early 90s, when we were creating new software, we were learning, there was a lot of learning in terms of loopholes in those software, and that's the time when there was a lot of research on software security. People found a lot of bugs, and we then over time we started learning. Towards the end of the century, we had pretty much good grip on traditional software security like web app security. And then over the years, now we are seeing a shift in terms of how these systems are deployed, where we are everything is backed by some kind of a hardware, or whether cheap or expensive. So typically we have come to the same stage, but this time it is more for the new technology and hardware. So if you compare that with software, you have plethora of information on the internet. You have OWASP for that matter, where you have top 10, you have testing guide, you have so many good tools, open source tools that you can use to test the security of the software. But at the same time, now when it comes to hardware security, there are no such organizations, and there is no such information. There is information, but it is pretty limited. So we are not there yet from a hardware security perspective. So if you look at the new technology, what exactly is broken, or what are the issues? With the new technology, you have new communication standards and protocols. You have new hardware. You have software that runs on those devices, software that runs on the cloud, and then you have privacy issues. So overall, if you look, even with the new communication protocols that are coming up, or the vulnerabilities we are seeing in the software and hardware are pretty much history repeating itself. They talk about the same thing. There are authentication issues, there are issues with overflows and things like that. So basically, if to err is human, what I've derived out of it is to repeat as human too, because we are just experiencing the same problems which we have overcome in the early years. So from the attack perspective, obviously we are going to see a lot of standard and legacy as well as traditional attacks. Typical attacks on web applications, on services, network services, and so on. They're not going to go away, because we are just creating more and more software. So these traditional attacks are going to stay. But what we're going to see an increase in is, one is the supply chain attacks. Now, when we talk about these devices and these sensors, attacking during the supply chain is pretty simple, especially for these common devices. So where you can get, and the problem is that these devices have so many loopholes that tampering with these devices, like putting in hardware implants or flashing a malicious firmware is pretty easy within the supply chain. The next is radio-based attacks. Now, with the whole IoT and machine-to-machine technology, uh, new radio protocols have gained a lot of popularity, because these new protocols promise long battery life. And because most of the devices, if you especially look at critical areas like industrial, these devices are deployed on the field, whereas there is no direct power source. So you need some kind of a communication method with these devices. So these new radio protocols promise long battery life, where you have the device deployed there for years with the same battery, because they use very minimal power. And so with this, then the researchers have now started to focus on these new radio protocols. You look at LoRa, Zigbee, Z-Wave, Thread, Weave. There are a lot of different protocols. Um, so and there we are already seeing a lot of research happening and a lot of vulnerabilities being found, especially if you look at it in this decade. You must have seen there were a lot of vulnerabilities found specifically in Bluetooth, Bluetooth low energy, Wi-Fi protocol, Zigbee protocol, all the newer protocols. And the reason why this has suddenly increased is because the usage of these protocols has suddenly increased or exploded, and so these are now coming in mainstream. And last and the most important is attack on the hardware. So now, before the whole IoT and automation thing, not many people or not many researchers looked at hardware as, one thing which would form a very strong or a very easy attack surface for even when we talk about enterprises. And this, again, because of popularity, this has become one point of research as well as attack. And this is not just limited to research. We have seen, again, a lot of examples where the attackers have gained access into the enterprise infrastructure through these devices. There was a case where some hackers got into a casino through their fish tank, connected fish tank. I think Target, the big retail giant in the US. There was an attack on Target as well, which is in the news, and the attackers got in through the HVAC systems and then pivoted into the network. So these form very crucial part of the attack surface, even though an enterprise specifically there is no relation in terms of IoT and automation. But what we don't realize is that IoT is now everywhere. You go into the office, we don't even know how many connected devices which are not part of the IT infrastructure are present in the office. I mean, just forget about office. Look at your home now. You have so many devices connected. If you just run a scan, you will be amazed yourself on how many different types of devices are connected. So with this, I think this was 6 to 7 years ago when we shifted our focus completely towards embedded security research. And so when we were starting in research, we looked at some of the devices and we thought to ourselves, hey, we have a very good experience in terms of security assessment for systems. How difficult would it be to hack a particular embedded device or an embedded connected device or IoT device, whatever you want to call it? Because from our perspective, the process would remain the same, right? What would change typically is the attack surface and the entry point. So we thought, it'll be pretty easy, throw any kind of embedded device on us and we'll beat the shit out of it. When we got these devices and we started our research, things were totally different. We ended up with this now. And one of the challenges is the attack surface in itself for any embedded device is just huge. And if it's a slightly complex device, it's even greater. You have the microcontroller, you have the storage, you have the sensors, you have the actuators, you have network interfaces, which may be Ethernet, wireless, Wi-Fi, Bluetooth, Zigbee, anything, proprietary radio communication protocol. So basically we ended up learning bits and pieces from here, bits and pieces from here, downloading a lot of open source software. Some of the most of the open source software would not work out of the box, so we ended up changing a lot of code. We bought different hardware. Some of the hardware were hobbyist tools. So basically we ended up working on those tools, scripting for those tools. at the end, we realized that most of our time was spent in writing code to make our test cases work. So and this was basically the start of how do we make sure that from our learnings, how do we make it easy for the community and as well as ourselves. So we started thinking, we went to the drawing board, and some of the challenges that we wanted to answer, or some of the problems that we wanted to solve, was one was the manual effort that it takes you to create a setup and then keep on running test case by test case. The other is the learning curve. Let's say you get a device, you get a new radio interface, you have absolutely no idea about how the protocol works. So you will go ahead, read the specifications, if it is open source, understand how it works, program a chip to send something, then you will receive. That wastes a lot of time. And then there are certain standard test cases which you can apply to different parts of the IoT ecosystem. Like if you have a microcontroller, what are the things that you can test on? If you are testing, if you are looking at the test points, what are the different protocols you can test on? All these are standard tests that you can run. But the thing is, when you have a hardware tool and a target device, these tests take a lot of time to run. So you have to create the setup, then run scripts, then record the results. If you're doing it for professional reasons, then you keep on copy pasting the results to a Word doc, and basically it creates a lot of mess for you. So what we basically wanted was, what if we could create a Swiss Army knife? So given any device or any IoT ecosystem you have to test, you have the Swiss Army knife with you. Let's say now it has Zigbee interface, the target device. You go ahead and run Zigbee test cases on it. If you are running a hardware test on the device through this Swiss Army knife, you go ahead and run the hardware test cases. Obviously, you will need compatible hardware for it, but making the hardware work, checking the scripts, all of that work will be taken care by us, and then customizing the test cases. So that's when I started working on a framework called EXPLIoT. I wrote it in Ruby and then realized that Ruby was probably not the language I would be working on, because of because there was not much support from a hardware tool perspective in Ruby. So I scrapped that project. I rewrote everything in Python, and the source code is available on GitLab, and our website is exploited.io. So basically, what I'm trying to create is a framework with which you can automate IoT security testing. The framework already provides you standard test cases which you can use to exploit, scan, analyze certain things. And using the same framework, power of the framework, let's say if you have a specific test case that you want to use for a device, you can go ahead and create your own plugin to do that. So on a very high level, this is how the framework looks like. I'll not be going into much details into it, but just to give you an idea, the framework also acts as a tool. So you get a command line interface. You have a protocol engine that basically provides the communication methods for the plugins. And on the right side, you will see the plugin modules. Those are basically individual test cases called plugins, which anyone can write using the protocols and interfaces available. And once you write and add the plugin, then you can access it through the command line interface. And you can also automate these plugins. Let's say you're going to release a particular device, and there are certain tests that you want to run against each release. you can just automate the plugins from 10 plugins or 15 plugins that you can just fire off, and they can run on their own and give you results. Typical smoke testing or regression testing that is performed in SDLC. And the only thing is these test cases are typically geared more towards security. So how does a plugin look like? Again, it is very simple to program. If you are even a bit familiar with the Python, it is very easy to create new test cases or new plugins for the framework. So there are basically three things that you need to do to create a framework. One is basically you have to specify what the plugin is all about, and that is pure English. You have to specify the name, summary, description, your name, the author's name, email address, the reference from where you got the idea, and the category the plugin belongs to. The next is the requirement for the plugins. Now, what is it required? What is required by the plugin to function? So, for example, let's say you're doing a network attack. So the plugin would require the IP address or the host name of the remote machine. So you specify that argument. It requires a port. Or let's say if it requires a hardware interface, then you specify that as a requirement, that please specify a device path for hardware interface. And then the last is a method which is called execute, where all you need to do is write your business logic. Using business logic means the misuse case or the exploit that you are writing, using the protocols that are specified in the framework itself. So if you have been doing security, I'm sure you must have heard about Metasploit as well. Think of it as something like a Metasploit, but geared only towards IoT exploits and security tests. So as of now, we have all these test cases and plugins available in the framework. For example, we have BLE, where you can run BLE scans, you can interact with the BLE devices, you can fuzz test some of the BLE devices. On MQTT side, you can interact with an MQTT server. You can even interact with the AWS MQTT broker. You can interact with CAN bus if you are working on cars or autonomous vehicles. You can ping or communicate with the DICOM server if you are in healthcare. And similarly, there is hardware debug port scanner. Now, hardware debug port scanner is the test cases are geared for our hardware tool. But going forward, we are going to add support for different other hardware scanners as well. So not just limited to our own tool. You can, for example, now you can fuzz test serial or UART console. You can extract or read or extract data from flash chips, from I2C based EEPROM chips, and you can also sniff and analyze Zigbee communication. So this is how typically it looks like. Once you run EXPLIoT, you get a console, and it is very simple to use. I mean, I have tried to keep it as simple as possible. So somebody who's getting into IoT security, wants to test certain things, can test it. So you just get the console. And on the console, basically there are two commands that you can use as of now. One is the list command, and one is the run command. So list command will give you a list of all the plugins available in the framework, and run command allows you to execute a specific plugin by providing its parameters. So these are, for example, this is the output of a list command, and as you can see, we have BLE plugins, we have CAN bus plugins, we have DICOM, I2C, and Zigbee auditor, Zigbee plugins, and so on. So there are some test cases which we, based on our learning in terms of when we pen test certain devices, some of the test cases have come from there. For example, ble.generic.fuzzcar is very interesting plugin where you can fuzz test the characteristic values that you send to a BLE device. So once, if you're familiar with BLE, the way the communication happens is through something called as characteristics. So you write, you read the value of a characteristic from the device, and you can write the values for some characteristics on the device. Now, the moment you can write some value, that is what we pick, and we try to fuzz test the write as well. Now, the thing is that value which is written into a BLE device, that is typically used by the application developer of that device. So let's say if it is a smartwatch and you are trying to write date time on the smartwatch to set it up. Now this date time value that you are sending will be parsed by the application developer of this device, not by the BLE chip itself. And this is where most of the problems come, when typical memory corruption issues. So we've seen uh, devices restart, some devices get bricked, some devices go into firmware upgrade mode, and so on and so forth. And similarly, there are certain lot of other test cases which are specific to either a protocol or a particular system. All right, I think, yeah, that's almost about it. Um, before um, so before I end, there's a couple of things that I want to mention. If you are interested in IoT security, and basically looking at where do I go ahead and learn IoT security, you can go to our website exploity.io. We have a free ebook there. It's around 230 odd pages of information on different aspects of IoT security. You'll find it pretty handy. If you're into AppSec, we've just released or published a website called Securecode.wiki, which is also open source. So if you are new to AppSec, you can go and read. If you are already experienced in AppSec, you can also contribute to the website by just sending a pull request to our GitLab server. All right, I think that's about it. I was probably pretty fast. Yeah. So
yeah.
Thank you and stay safe. Yeah.
Thank you, Asim. And we now open the floor for any questions. If anybody wants to pitch in any questions, please go ahead.
Yes, we can take questions. Oh yeah, have you looked at any LP WAN testing like CAT-M1 and narrowband? So the answer is very good question. The answer is not yet. We have not had a device with that, and plus, yeah, there is a lot of already pending work, but there is definitely interest for us to look at these technologies. If you have some experience in it, and if you want to contribute to it, just shoot me an email. I'll just write down my email as well, so you guys know. So we are taking it one by one. As of now, we have done it for Zigbee. The next most likely would be wireless HART. Uh, if there are any other protocols that you think are widely used, we will definitely look at that as well. So yeah, you can share that with me. Yeah, Laura is Laura as well. Yes. So Zigbee, Laura, we have already started doing research on. I think we would be able to add some kind of test cases for Laura by next quarter, hopefully.
Anyone else with any questions? You can rather type in the chat section as well. Assume you have one more.
Yes. From our testing perspective, we do that. But from a test case perspective, I think there is none as of now in the exploitative framework. Plus, it would typically depend on what protocol the device uses for the updates. So, for example, some devices would be only BLE. Where you can get access to the firmware on the mobile. Some devices would be only LTE or 5G or whatever. So the test cases there would be typically more difficult to achieve through the framework, whereas through BLE, if there are any standard test cases, I think that can be easily added to the framework.
Anyone else with any questions, or we can close this call?
All right. Have you ever done a test on a car that uses IoT? Yeah. So if you look at the car itself, I would call it one of the most complex computer systems on Earth. It the car itself or the vehicle itself is a combination of so many different ECUs itself. So have we ever done it? Yes. We professionally test vehicles from the perspective of the framework. We have very simple test cases for CAN communication as of now. And again, going forward, we will add more test cases. So the current test cases are very simple. They are CAN read, CAN write, and CAN fuzz. And then from a vehicle perspective, that the again the attack surface is very huge. So you have CAN on the hardware side, which is connected. The ECU itself, the ECUs itself will have their hardware. Then you'll have the infotainment system, which is connected through CAN, and then has a Wi-Fi interface, has a BLE interface, and has some kind of an operating system running in itself. So that itself becomes a system to test. Yes, I think that your car has a SIM now with the built-in Wi-Fi. I think you should also look at the research that Charlie Miller and I forgot the other person's name. They did on so they had written a very elaborate research paper. Basically, typically would give you good ideas on what are the things to immediately look at. So for example, if there is Wi-Fi, then what are the things that you can look at from the Wi-Fi perspective? What are the ways in which you can get into the infotainment system? Does it take USB? If it takes USB, are there any default files or anything which are there on the USB? So yeah. There are a lot of interesting areas that you can look at.
Okay. Any more questions? Anybody from the attendee list? Any more questions?
All right, till the time we are waiting. So I remember speaking to someone from, I think OWASP Jakarta many years ago, when we were looking at doing Nullcon conference in outside India. I think that time there was a discussion around some OWASP conference that was going to happen in Jakarta. I'm not sure if that happened. Is anyone aware of how do you guys have any plans of the conference, or has it happened earlier?
I guess so. We do not have the correct person to answer this question.
Okay.
Okay. I guess we don't have people from Ghana or the Jakarta chapter.
Yes, I think AppSec. Yeah. I don't remember who I spoke to, but his name had cool at the end. I think that then that time there were plans of doing OWASP AppSec conference in Jakarta. Right, I'll just mention the website as well on chat. This is for the IoT hacking book that is free, and then there is Securecode.wiki that is mostly for secure coding and examples. And then I've given my email address, so if you have any questions, you can connect to me later as well.
Okay. So thank you so much, Asim, for this informative session. And it was really a good time to know about exploiting. So yeah.
Thank you.
Thank you so much.
someone. Yeah, thanks
Thanks,
everyone. Thank you so
thank you.
much. Bye.